All right, let's dive into a topic that is absolutely critical if you're working in dental materials research. We're talking about how to measure the hardness of a dental resin and actually trust the answer you get. It really all boils down to picking the right test, especially when the thickness of your sample can completely change the game. So, just imagine this for a second. You've spent all this time carefully prepping a 1 millimeter thick resin sample. You run your hardness test, you get a number, but is that number really telling you about your resin, or is it telling you about the super hard surface the resin is sitting on? This is, without a doubt, one of the biggest traps you can fall into. And this right here is the perfect way to think about the core problem. It's called substrate influence. Just picture your thin resin sample as a yoga mat, and the hard stage underneath it is a concrete floor. If your test pushes down too deep, you're not measuring the squishiness of the mat anymore. You're measuring the hardness of the concrete. And just like that, your results are totally off, and the data you actually need is gone. So, how in the world do we avoid measuring the concrete floor? Well, it really comes down to three main testing methods, and each one has its own special powers. Let's meet our contenders: Vickers, Knoop, and Martens. Here's a quick look at our toolkit. You can think of Vickers as the gold standard, right? It's awesome for general reporting and for comparing your results with tons of other published papers. Knoop, on the other hand, is the specialist. It's your go-to for really thin layers and for figuring out depth of cure. And Martens? Well, that's the high-tech diagnostic tool you bring out when you need to get deep into the mechanics of the polymer itself. Okay, so let's put these methods head to head. We're going to start with Vickers and Coop, since they're the ones you'll probably reach for most often when you're asking questions about curing. And the key difference between them really just comes down to the shape of the little dent they make. And this shows you everything you need to know. If you apply the exact same amount of force, that pyramid-shaped Vickers indenter digs pretty deep into the material. But look at the Knoop indenter. It's long and skinny, so it creates a much, much shallower mark. Now, for a thin sample, this is a total game changer. Knoop immediately gives you a huge advantage by slashing the risk of accidentally hitting that concrete floor we were talking about. So, what does this actually mean for you in the lab? Well, if your main goal is to compare your findings to the huge library of existing research out there, Vickers is probably your best bet. It's just the most common standard. But if your mission is to map out a really precise depth of cure profile on a thin layer, Knoop is definitely the safer, more accurate choice to make sure you're only measuring the resin. And now for our third contender, Martens hardness. This one, it's a completely different animal. Instead of just measuring the dent that gets left behind, Martens actually records the material's behavior during the entire test. It's kind of like the difference between seeing a footprint in the sand versus watching a slow-motion video of the foot pressing into it. This gives us way more information, like how much the material bounces back. That's called elastic recovery, or how it slowly deforms under constant pressure, which we call creep. So here's the bottom line. Vickers and Knoop measure the result, the permanent scar left behind after the test is all over. Martens measures the process, the material's dynamic response while the whole thing is happening. For really complex materials like polymers, this makes Martens the perfect tool for deep mechanical research, even if it is a little harder to compare with older studies. Okay, with all that in our back pocket, let's get right to the core question of the day. You've got a resin sample. Maybe it's a thin 1 millimeter layer, or maybe it's a chunky 4 millimeter block. How do you decide which test to run? It actually breaks down into a really simple three-step decision. First things first, define your goal. What question are you actually trying to answer? Second, take a good look at your sample. Is it thin enough for that concrete floor to be a real risk? And third, based on those two answers, you select your method. Simple as that. And here we have it, the ultimate decision-making cheat sheet. Let's walk through it. For a thin 1 millimeter sample where you absolutely need to know the depth of cure, Knoop is your guy. Preferred, for sure. Now, if you have to get a Vickers number from that thin sample to compare it to another paper, you can, but you got to use a very low load and be really, really careful. Now, for a nice thick 4 millimeter sample, that substrate influence just isn't a problem, which makes Vickers perfect for general comparisons. And for that deep dive into polymer mechanics, Martens is the answer, no matter how thick your sample is. But, and this is a big but, choosing the right method is really only half the battle.
Before we wrap things up, I have to give you a critical word of warning. Even with the perfect test, there are a bunch of other factors that can still mess up your results.
Resins are not simple materials. The amount of force you use and how long you hold it there can literally change your reading. The material's hardness can actually keep increasing for hours after you think you're done curing it. Even something like the surface condition, say an unpolished oxygen-inhibited layer, or just the temperature in the room can shift your numbers. This is exactly why having a perfectly standardized protocol isn't just a minor detail, it is absolutely essential if you want data you can actually trust. So, as you head back to the lab, I want you to always ask yourself this one fundamental question, because the answer is the key to making sure your data is accurate, reliable, and a true reflection of the material you've worked so hard to create. Thanks for joining us.